Good afternoon, class, and welcome back to Chapter 4.2. Here's part 2 of the video, Graph Linear Equations. I didn't put this with the first video because it's a little bit different and a little bit more advanced than the introduction that we got yesterday. So, graphing an equation with a restricted domain. So remember, domain is our x value. So restricted means that there's guidelines now on what our x value can be, and the problem will tell us that. Okay, and we'll see that in a second. But here are the key steps that you need to take to solve this equation with a restricted domain. So step 1, make a table, which we're used to doing, and you'll see that in the next problem. And now on these, the table we'll use different domains than the ones we're used to. You know, we're used to using domains that are similar to this. This time on these tables we may use different domains, and I'll tell you why on the next slide. Step 2, after you find your points, your domain and your range, you'll plot those points. You'll connect the points with a ray, keyword, because the domain is restricted. So it is not a line that continuously goes in both directions. It's going to be a ray. Okay, so we will have a starting point and an ending point. That might not be the direction it goes. It could go in that direction, but you'll see. And then identify the range. From the graph, you can determine the restriction on the range. So you're going to have to write a restriction on the range now, because in the problem it will give you the restriction on the domain. We're going to identify the restriction on the range. And then write the restriction as an inequality. So let's attempt this problem. Graph y equals negative 1/2 x plus 4 with domain x is greater than 0. Identify the range of the function. Now, let's take this out of the equation for right now. Let's just focus on graph y equals negative 1/2 x plus 4 with domain x is greater than 0. So we know that they want, in this problem, any number that is greater than 0 or equal to 0. Okay? That's what that inequality tells us. Now, what I went back and told you, we might not be using negative 1, negative 2, 0, 1, and 2. Because if you can look, the number that occurs before the x here is a fraction. And when you plug numbers in, you usually want to get a whole number out. We do not want decimals. So here I've selected domains that will give us a whole number out. So if I plug in 0 for x, negative 1/2 times 0 is 0, 0 plus 4 is 4. Okay. Now if I plug 2 in, negative 1/2 times 2 is negative 1. Negative 1 plus 4 is 3. Plug 4 in, negative 1/2 times 4 is negative 2. Negative 2 plus 4 is 2. So we see a pattern occurring here. So if I plug in 6, negative 1/2 times 6 is negative 3. Negative 3 plus 4 is 1. And then if I plug in 8, it's negative 4 plus 4, which is 0. So now I have my ordered pairs. These are my ordered pairs here. And now I have to label my points on the graph. Okay? I'm going to plot them. So if I go 0, 4, 2, 3, 4, 2, 6, 1, and 8, 0. I'm losing dots here. Then 8, 0. Okay? So I've plotted my points. Now, the next step says you're going to create a ray. So I'm creating this ray, connecting the dots here. I'm not sure why that happens. I apologize. I'm going to find out though. So go back here. I made my table. I plotted the points. I made my array based on the restriction. And now I have to write and identify, let me erase this now. I have to identify the range of the function. So when I'm looking at my graph, okay, or you can go back to your table, I have to tell the restriction on y using an inequality. Okay, so inequality can use any of these signs here. So what can y be? When I look at this graph, what could y be? So y could be 4, y could be 3, y could be 1 at some point. So I know, based on this information and seeing, remember this is the y-axis here, right here. So I know based on this information, it can be any number on the y-axis less than or equal to 4. So I know that it's going to be y is less than or equal to 4. Okay, look at the y-axis. Okay, right here. And think, the line, where does the line fall within that y-axis? And remember, this array will go on forever, so it will be decreasing forever here. So, y is less than or equal to 4. So any number I plug in here, if I plugged in a 5, can it be 5? Can this line be 5? And it cannot be 5 based on the restrictions that we have on the domain. So that would not work out. But it can be any number less than or equal to 4. Okay, more than likely, okay, sometimes more than likely, you can always look at what your top number may be here based on the numbers you select. It all depends on the numbers you select. But again, go back to what the equation is and making sure that you plug in numbers for x that will give you a whole number out. Whole number. That's why I used even numbers here. Okay, to get a whole number as my range. It's easier to plot points. Okay, so go back to these steps. Okay, have these down in your notes so then when you work on this homework problem, okay, you can go through step 1, create the table, step 2, plot the points. Okay, number 3, connect the array. Okay, based on, okay, go back, make sure the table is based on what our, okay, restriction here is on the domain. So that's very important. Then identify the range of the function. So go through all those steps, okay, to answer this homework problem. So if you have any questions, please email me. This is the most important part. Think about after you make that array, when you create that array, based on the table and your information from here, what can y be? Okay, and write that as an inequality. What are the restrictions on y? All right, I hope you have a wonderful evening. Let me know if you have any questions. Take care.